So with that calculator that you have out on your desk or on your iPad, let's just start with an easy one. 7C2. Use your calculator and get the answer. Now, can you tell from that whether I think order matters or not? Yes, you can. Does order matter or not? Focus. Does the order matter on this one or not? No. If it's a P, the order matters. That's why I say the order matters. All right, this one, the order didn't matter. So I'll give you an example. It's 7 kids. They just are going to pick 2 of them that get to, I don't know, if there's, let's say that there's a donkey that's to be ridden in this party. The first 2 kids to get to ride the donkey. Well, there's a lot of different sets of 7 kids that you could, get little sets of 2 out of the 7. How many is there, Vivian? What did you get? 21. 21 different sets of 2 kids. Does the order matter on this one? No. Now, does the order matter on this one? Yes. So that means same question, but now the order matters. So like maybe it's the kid who gets to ride in the front of the donkey is first. So the order matters. If you get Nora and Dashiell, it matters because one of them gets to ride in front and the other one rides in back. So if they are keeping track of what order you're in, then order matters. Use P. All right, Rena, what did you get for that one? 42. Notice twice as much. Why? Because every pair of 2 kids, you could switch them around because if the order matters, then it's going to be different. Rena, can you write over your name tag with that? So I can actually see it. I know your name, but I still want to be able to read your name tag. Okay, so the next thing is, what if I give you a problem without the P thing? Can you figure out what to do? Well, here's an example. This is either a P or a C. I got 7 books. I put them on a shelf. I'm picking all 7 out of the 7. I want all 7 of them on the shelf. I could arrange them in many different ways. How many different ways could I arrange them? So it's amazing to me that a lot of kids will sit there and go, I don't know if order matters or not. If the whole point is that there's different ways to arrange the books, then order matters on this one. Besides, if you choose 7 books out of 7, if I did this, the answer would be 1. And you should be like, there's only one way to arrange all those books? That doesn't make any sense. Well, that's because you didn't do the one where order matters. You should have done 7P7. All right. So, Rena, what'd you get? Haven't done it yet? Okay, I'll let you catch up. Everybody, type that one in. I will call on somebody. I'll pick a random person with the dice of destiny. All right, could you just shut the door back there, please? There's a lot of hallway noise coming in. All right. It is row 5, person 4, Mr. B. What did you get?
5,000.
Here, I don't know where your name tag is. We'll find it later. Just have a seat. Just have a seat right now. All right, I'm in the middle of the video. Sorry, we'll talk later. So what did you get? One more time.
5,000.
5,000 what?
5,040.
5040. Raise your hand if you got 5040. Good. All right. So now that was arrangements of books on a shelf. And did order matter? Yes. Yes. Otherwise, there's no point. You got 7 books on a shelf. There's nothing to do with them. If you're not keeping track of what order they're in, there would be no problem to do. Okay? All right. So next kind. This is the kind where you make a tree. I'd like you to make a tree like this for this scenario. You ask your next door neighbor lady who is elderly if she wants you to mow her lawn. Because you're trying to make some money over the summer. And you're saying, hey, maybe she'd like me to mow her lawn this summer. Well, she's either going to say yes or she's going to say no. Let's say there's a 0.7 probability she's going to say yes. Then, that was for mowing the lawn. We're going to follow that one up with raking. This was for mow. This part's for rake. And she's either going to say, yeah, or you should rake it too. Or no, I'm fine. Yes or no. And let's say, I'll give you the different one here. Let's say that you're 50-50 on whether she's going to say yes on the raking. Same on this one. You should be able to fill out all the other parts of this and give the answers that each path yields. And you do those by multiplying decimals. Use your calculator. Practicing for the test. When's the test? Not tomorrow, but the next day. It's Friday. The test is Friday. And I know some people's tests are going to be different, but I'm getting you totally ready for the test on Friday. All right. So first off, I don't know that decimal. Christian, what decimal should go there? If they're both 0.7?
Oh, 0.3.
That wouldn't make any sense. Okay. 0.3, that makes sense, because then together they add up to 100%. Eli, what's this one right here?
0.5.
Excellent. And then this has to be 0.5, because they add up to 100%. And then I'm multiplying out. I'm going to use a highlighter here to highlight this path. That is yes, and then yes. The next door neighbor lady wants you to mow and rake. That is a 0.7 times 0.5 is 0.35. Raise your hand if you had that one right. Cool. Now do the rest of them. Miss Chu, what did you get for the next one? Yep. And for the next one, Miss Reddy. Yep. And then the last one, can you do it? 0.15 again. So this adds up to 0.7 and then 0.3 adds up to 100%. Does that make sense? All right, now what if I said, what's the probability that she's going to either say yes to both or no to both? Well, yes to both was this one. No to both was this one. And what if I say or? That means add. That means there's a 50% probability that one of those two things would happen. If I say or, you add them together. So 35 and 15 makes a total of 0.50. That means there's a 50% chance that she'll either say yes and yes or say no and no. Okay. That's how those complicated ones work. All right. The next kind is... I'm going to jump right into teaching you the new stuff for today. Except there's one kind that isn't in the notes and there's one kind that is. Here's the kind that isn't in the notes, and therefore I want to do this separate with you. All right. If you have the word toy, do you get you could rearrange the letters? And then it could be yacht, or it could be oit, or it could be toy, or, well, basically you could have a whole bunch of rearranging of the letters. If you want to know how many answers there are for these, yeah, you could write them all out, but it's kind of a pain in the butt. And you're probably going to forget one, like I forgot a couple. Okay? So here's how you do it. Would you agree there's 3 letters? Then it is something called 3 factorial. All right? Now, what the heck is a factorial? Does anybody remember what this is? You learned it at one point. I think it was in geometry. Does anybody know? All right. There's a way to do it on the calculator, but this is honestly easier to do in your head. It means 3 times 2 times 1. Would you agree that's pretty easy to do in your head? 3 factorial means 3 times 2 times 1. So the answer is 6. And there are 6 ways to rearrange this word. 6 total ways. And I got 4 of the 6 here. Maybe I can just finish it. I've got Y in every spot. I've had T. I have never had the T in the middle. So it could be O, UTY, or it could be YTO. There's my 6 ways. But you can do that with 3 factorial. Now, some of you are going to want to know where it is in the calc, so I'll tell you. All right, everybody hit the math button. Then everybody hit the probability, PRB. And do you see an exclamation mark in there? Under math, probability. You see the exclamation mark? It's like the 4th thing down. If you want to do however many letters there are, if there's 3 letters, you do 3 factorial. So if I'm going to do 3 factorial, I got to put the 3 in first, though. So I really should have told you to hit a 3 first. And then go to math, probability, exclamation mark, which is called factorial in math class. 3 factorial is 6. If you want to just do these in your head, it'll be fine. Because honestly, we aren't going to do anything that are really huge. Let's say I even did 7 factorial, just to make sure you get this. That means 7 times 6 times 5 times 4 times 3 times 2 times 1. You always end with times 1, which doesn't really even do anything. So if you want to go up from the smaller numbers first, just do it in your head. It works. 3 times 2 is 6, times 4 is 24. And then you might be like, oh, this is getting to be a pain. Then maybe you grab your calculator and times the rest of them out. But just to make sure you know how to do it, everybody put in 7 first, then factorial, and hit enter. 7 factorial. You get 5040? We had that problem earlier. 7 factorial is 5040. If you want to do it by 7 times 6 times 5 times 4 times 3 times 2, it would work. Okay, now there's only one other thing that we got to do to make that a little more complicated, because honestly, otherwise that would be really easy. I mean, train. It's got 1, 2, 3, 4, 5. You go 5 factorial, the end. Like, that's really easy, right? So, of course, it has to be a little more complicated. You're in higher algebra. So, what if it was the word rare? What's different about that than all the other examples I gave you? Yes? It has 2 R's. And that makes the problem a little harder. But it's not that hard. It's still 4 factorial because, 4 total. So you go 4 factorial, but you got to divide it by something. You got to divide it by 2 factorial because there was 2 things that repeated. You could totally use a calculator for it, or you could totally just do it in your head. 4 times 3 times 2 times 1 over 2 times 1. And I mean, look at how easy this is. That cancels. 4 times 3, 12, done. No calculator. It's so much easier without a calculator. So why is there a 2 on the bottom? Because there was 2 things that repeated. All right, would you agree the word tomato has 2 T's and 2 O's? Well, there's 7 things, so it's 7 factorial over, and I don't think we'd even give you anything that's this hard, but there are 2 things that repeat. So 2 factorial and an extra 2 factorial, because there was 2 things that had 2 in it. Okay, so that would be 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. Well, I'm just going to say that's like 4, and I'm going to cancel off this 4. Boom. And now I could use my calculator to do the rest. 7 times 6 times 5, and then 3 times 2 is 6. So 7 times 6 times 5 times 6. All right, I'm going to get one last nice normal one, okay? For those of you that are kind of clueless on this kind of thing, Mother's Day is coming up on Sunday. To mothers is kind of a big deal. Strongly recommend that you write mom or dad a note. Okay, if it's
if you have mom at home, or even if, wherever mom is, I recommend you write a note because that is very special to moms. I had a mom, and my wife is a mom, and it means a lot. Okay, so don't be the kid who just completely forgets that it's Mother's Day. All right, so anyway, so I got the word mom. Would you agree it's got 3 letters and therefore it's 3 factorial, but isn't there a repeat? And therefore, divide it by 2 factorial, because there was 2 m's. Can I do that in my head? Yeah. If you have to use your calculator, you know it's under math probability, but I hope you could do this. And then look, they're identical. They cancel. Answer's 3. You might be like, what do you mean there's 3? There's 3 ways to write those letters into words, like mom or O-M-M, or there's only one other way to do it. M-M-O. There's no other combo but those 3. Because the answer is 3. Okay. Act like it's your test on Friday. Here's the question. Trying to find a kid's name who's got repeated letters. All right, here's the word. The letters in the word Christian, C-H-R-I-S-T-I-A-N, one of the kids in here. Do you see that there's a repeat? So then use your calculator, because this is a pretty big one, to figure out what factorial over what factorial, and use your calculator to get the final answer. In case you have a counting issue, there are 9 letters, so it's 9 factorial, but that's not the final answer. That was under math, prob, or PRB. 9 factorial. Dang, that's a lot of different rearrangements. But if I just said the answer was 362880, it means I forgot to do the divide by thing. Liliana, what should I divide by?
2 factorial.
Because there are 2 I's. If there had also been like 2 H's or something, then I would have put another one down there. But this might be as intense as we would go. So then it's divided by 2 times 1. Well, that's really just divided by 2, right? So I'm going to take my calculator and say divide by 2. The answer is 181,440. That's how many different ways you could rearrange his name. Okay. Now the last thing, last method. And after I teach you this, all I got to do for the rest of today and tomorrow is review everything, and then the test is Friday. Okay. So here's the last kind of problem, and it is about casinos? No, it's about expected value. Do you get, if you go into a casino, you should not expect to win? On average, do you get it that people that go in there lose? Does everybody lose? No. Otherwise, nobody would go in there. If you lost every time, you'd be like, this is no fun. You win sometimes and you lose sometimes. On average, that's kind of what expected value is. You expect to lose. And here's how I can tell you an example. They did a thing at one of the local casinos where they figured out their average winning per person. And it came out to $50. And do you think that the average person won $50? No. On average, the person would go in there and lose $50. But it doesn't look like $50, $50, $50, because otherwise people would never go. Lose $50 every time, right? So sometimes they win $250, and sometimes they lose $300. And on average, the expected value is like losing $50 every time you go in and play at a casino. Okay, so how do you figure these out? This is what you got to write down. Probability times amount, then add. That's what you do on all of these, is you take the probabilities times the amount that you get, and then add them. I will give you the simplest one in the world. I have a $1 bill right here. So imagine I put it in an envelope, and then I say, you get to pick an envelope. And it's either going to have $1 in it, or, well, that's the only choice. It only has one envelope, and there's $1 in it. Well, if you played this game, wouldn't you expect to win $1? That's your expected value, right? What if there's two envelopes, though? And one of them doesn't have anything in it. Now do you get, on average, if you don't know where the dollar is, on average, you're not going to win on average $1, because there's two envelopes. So you got to take the probability you're going to win. There's only 1 in 2 chance. Times the amount you're going to win, which is $1, and then add it all up. Well, there's only one thing to add. There's only one thing that would make me win. So I don't have to add it up. The other envelope has nothing in it. So my average expected value is 50 cents. Because you're going to win some, you're going to lose some, and on average, you won't get $1 every time unless you're psychic and you know which one has the $1 in it. So you take the probability you're going to win times the amount you get if you do win, and that's your expected value. All right, so this comes up in the real world. Nobody offers you envelopes on the street, but people offer you a extended warranty all the time. Almost everybody in here has a smartphone. And when you bought that phone, or when your mom or dad bought that phone, they were offered a warranty. So there was 2 things that could happen. There's 2 outcomes. Everybody make a chart like this, please. And this is where we go outcome. Your phone is either going to keep working and it's going to be fine and it'll just keep working, or your phone is going to break. What is the probability of that? Well, that we're just going to have to make this up. But you can bet that Apple knows. Apple has probably done the math and they know what probability is that your phone's going to break. Just give me your gut feeling. You've had a phone for a while. For a typically a warranty is like a 2-year deal. Over the next 2 years, how many of you would say your phone screen at least is likely to break? Be honest. How many of you think your phone's going to probably break over the next 2 years? 1, 2, 3, 4, 5, 6, 7. Okay, so we'll just say it's 7 out of 24 chance that it's going to break. I know that wasn't very scientific, but then that means the other part, which would be 17 out of 24 chance that it will just keep working. There's your probability. We'll give you that number. You won't have to guess that number. We'll tell you the probability that the thing's going to break. What's the amount you get if you bought the warranty? Well, let's keep it really simple. Let's say the phone costs $300. A lot of phones are in that neighborhood or higher. The phone is $300, and let's just say that it was really simple. They just completely replace your phone. If your phone breaks, you get $300. And you have to get the phone back, but basically you get all your money back if your phone broke. If your phone works, think about this. Your amount you get is nothing. Does anybody say, hey, is your phone working? Yeah, my phone's working. Well, here's $300. No, that doesn't make any sense. They don't give you anything if your phone is working. If your phone breaks, they give you money because you bought the warranty. Now, I know a lot of you are like, but it costs money for the warranty. Yeah, we'll figure that in at the end. All right, what did I say it was? Probability times the amount. Probability times the amount. So I'm going to do this times this. And then with a separate highlighter here, I'm going to do this times this. That's my favorite one because, you know, timesing by 0, guess what it equals? 0. Would you all do the other one, though? And if you're like, how do I put in 7/24 on the calculator? I would put it in parentheses, and that works for all calculators. I know some calculators you can put in fractions different ways, but if you just put it in parentheses, I guarantee it'll work. 7/24 in parentheses times the 300. Go ahead and do it. I'm going to call on a random kid. Put it in parentheses. All right, random kid. It's row 2, person 2. Zach, that's you. 87 point, I think it's 0.5, isn't it? Maybe you rounded funny. Anybody else get 87.5? That's what I got. Okay. 87.5. That right there is what the warranty should cost. In the real world, don't you get though that Apple wants to make money on the warranty? They're going to charge you more than that for the warranty. All right, so I took the probability times the amount and then I added it up. Well, 0 plus anything is just that. So it's 87.50. That's what the warranty is worth. But you will have to pay $100 for it. That means you're going to lose money on average. You know why they push those warranties so much? Buy AppleCare. Because they make money. On average, they will make money. They don't do things to on purpose lose money, that's for sure. So I'm going to subtract 100. Because that's what the thing costs. And now it ends up being a negative number. Negative 12.50. That is your expected value. It's the number at the very end after you factored in the cost. On average, everybody that buys the warranty loses $12.50. See why they sell them? Like they already made money on the phone, and then if you buy on average, you buy the warranty, you'll lose money. I'm not saying it's stupid to buy the warranty. A lot of people buy insurance because then they don't have to worry about it. Then you can like drop your phone and you're not all stressed. There's good things to it. But they make money because that's what the companies try to do. They try to make money. So they sell something so that you lose $12.50, and of course that means the company would make $12.50. All right, what do you do again? Probability times the amount you're going to get, and then you add them up. Here was your probability. Here was the amount you get, and then it's easy to add them up because 0 for this one. It's just really that one. But don't forget to subtract the cost of the warranty. All right, let's do one last warranty question, and then you'll pretty much have this done. Okay, so here's another warranty problem. Real life, there's a TV. Let's say that the TV is $400. You can get a decent TV for $400. They offer a warranty for $50. And it pays you all $400 back if your TV breaks. So you can either buy a new one or you can use that money to fix it or whatever. In the real world, it's more complicated because then they would really rather repair your TV because it doesn't cost them that much to repair it. So a lot of times it's a repair warranty, but we're keeping this simple. You get $400 if it breaks. So you have to make this little thing. Everybody make this little thing. It either works or it breaks. Those are your only two choices. And you do the probability, which I haven't told you yet. And this is the amount you get. Probability that it works in the real world, only about 10% and less of items ever break. 90% of the time they work. So I'm going to go 0.90 for works and 0.10 for breaks. 10% chance it's going to break. And the amount you get? My TV's working. Give me money. That doesn't make any sense. My TV broke. I want my money back. That makes sense. So you get nothing if it works. You get 400 if it breaks. Now let's see if you can finish this and tell me. Remember, it costs $50 to buy the warranty. Try to figure out what your expected value is. P times A, add them all up, factor in the cost at the very end. You'll use your calculator to multiply some stuff. My favorite one is timesing by 0 because I get 0. I times those together, I get 40. You guys get 40? Cool. Factor in the cost of the warranty though, and you got to subtract off 50, and you lose 10. That is your expected value. Raise your hand if you had 10. All right, cool. You learned how to do expected values. That was the last thing. So I'm just going to do one little wrap up now of all of probability. Okay. The first kind is super simple, which we practiced earlier. It was just like 3P2. And the only thing I'm scared about is that some kids are going to forget which one has the order matters. Which one order matters? The P. So if it's a race, you use a P. If it's not a race, if you don't care about the order, like a pizza, you're putting toppings on a pizza, you don't care what order they go on, then it would be like this kind. All right, so knowing the difference between those two is really important. Pausing for a second. Okay, the next thing is trees. I'm going to just give you one that should be simple. We're going to do another yes-no one for this part. But for this, we're going to roll a die, and we're either going to get 1 and 2, or we're going to get 3 and 4, or we're going to get 5 and 6. Do you get those are equally likely to happen? Then you should be able to figure out this probability here. This is a die. You know, it's singular of dice. What do you put here, here, and here? And it'll be the same exact thing for here, here, and here. Can you make a tree like that? All right, did you figure out that this is 33% chance? Raise your hand if you figured out 33%. Nice. And then to finish the tree, you'd have to actually multiply them all out. Let's not do it. It'll take a long time, but I'll just do this one route here. Say I went this way, and then I went this way. This answer, you do 0.4. Clearing my calculator. 0.4 times 0.33. And I get 0.132. That's a 13.2% chance that that would happen. Okay, so that's how trees work. Then, name a sport that you enjoy. Noah. Okay, in soccer, let's say that you have, it's just you and the goalie. No, wait, that's actually make it even simpler. It's a penalty kick. So you are kicking. You don't have your phone out, do you? Okay, good. You are kicking, and there's a goalie in between you and the goal, and you're going to kick it. Let's say that you have a 75% chance of making it. Okay? But let's say you get 2 of them. And I want to know what's the probability you make both. Do you remember you'd put in 2, and you want to make 2, and you put the 75 in the middle, and this was a binom. Anybody know the next 3 letters? PDF, very good. If you forgot where this is, I'll remind you. Grab your calculator. First, we got to go to binomial PDF that's under DISTR. D-I-S-T-R, that stands for distribution. It's underneath the arrow keys. And it's on a second key. So it's on you hit the blue second key first, and then you hit disturb. Once you did disturb for distribution, you arrow down a whole bunch of times until you find binom PDF. And then that comes up on your screen. And the first thing they ask you is trials, which we had 2 trials. The probability, which we had 0.75. That's the P. And this last thing is called the X. It's how many you want. And we wanted 2. So it's going to do 2, comma, 0.75, comma, 2. Now, if you had trouble putting that in, you should ask me in a second how to do that. If you did it right, you got a decimal that starts with 0.5. How many of you got that? Decimal that started with 0.5. All right. It is 0.5625. Now, I'm going to swing past. Prove to me that you know how to put that in. I'm going to look at your calculators. While I'm doing that, you can start your worksheet. But I'm going to pause for a second here. I might do one more practice problem with you, but I'm going to hand the worksheets out while I walk around and prove to me you can do this on your calculator. Don't just type this in your calculator. I can tell. Okay? Show me that you did this on the calculator. If you don't know where it is, ask the kid next to you. They'll help you. It's under distributions. Disturb. I'm going to pause while I hand these out. Okay, I forgot one kind I want to tell you, and it's on the front page of the worksheet. Everybody look at problem 4. Look at problem 4 real quick. This is not the answer, but it's like this. 5C3 times 4C2. Okay, that is not the right answer for this problem, but this is like mysteries, and this is like science fiction books. And this is how many you're picking out of the group. Okay, this is how many there are, and this is how many you're picking. And you always take the C's, because the order doesn't matter on this kind, and you multiply. So your answer will look like this for problem 4, but the numbers are different, of course. Okay? But this is the kind where you put something C something and times it by something C something. All right? That's when you have, for instance, I don't know, there's a bunch of freshmen, and I'm going to pick 3 of them. And there's a bunch of sophomores, and I'm going to pick 2 of them. All right, so that's an example of how to do number 4. Yeah, I think this will be a good review for you. And then tomorrow is the really more intense review, because we will only be reviewing tomorrow. So, like, I don't have to teach you anything new now. And then Friday's the test. Okay, that's all I have for the video for today.